This essay example, as well as thousands of others, is available in text format on our website for free and without registration. Simply Google IVPanda Free Essays.
The first objective of this experiment was to monitor the hydrolysis of Tert-Butyl chloride by titrating the hydrochloric acid produced during the reaction with a standardized sodium hydroxide solution. The second objective was to confirm that the rate of the reaction is directly proportional to the concentration of the Tert-Butyl chloride if the temperature is kept constant. Experimental summary. Hydrolysis of Tert-Butyl chloride takes place through an SN1 reaction, a nucleophilic substitution reaction. There are various effects of the solvent on initial reactants, reagents, and intermediate products. The interactions can increase or decrease this reaction. This experiment investigated the effect of concentration on the hydrolysis. The instant rate of reaction of T-butyl chloride and water could not be measured using simple laboratory equipment. It was measured using the incremental rates method. First, it was necessary to determine how much hydrogen chloride was formed over a short period by allowing the hydrogen chloride to accumulate over a time period and then measuring how much sodium hydroxide was needed for titration of the accumulated hydrogen chloride. Repeating this process with numerous time increments made it possible to find the rate of reaction as a function of time, as illustrated by Nivaldo. Results. The reaction was of the first order. In a first-order reaction, the rate equals K, T-butyl chloride, is 1. The rate of reaction was directly proportional to the concentration of T-butyl chloride. Calculations. 1 mole of T-butyl chloride yielded 0.1 moles of hydrogen chloride. Therefore, the number of moles of hydrogen chloride produced during the course of the reaction was a measure of the number of moles of T-butyl chloride reacting. The number of moles of unreacted T-butyl chloride was equal to the total number of moles of T-butyl chloride minus the number of moles of hydrogen chloride produced. Pavia states that mass product equals moles limiting reagent X molar ratio. Molar ratio A/B equals 1 divided by 1 is equal to 1.0. Moles actually used. A equals 0.05, B equals 0.12. Molar ratio A, B actually used, 0.05 divided by 0.12 is equal to 0.42. The ratio of A, B was less than 1.00. Only 0.05 moles of the 0.12 moles of B would be required to react with the 0.05 moles of A available. Since 0.05 is less than 0.12, then B is in excess, and A is limiting. Discussion. According to Pavia, the limiting reagent sets the maximum amount of product that could be expected. The actual number of moles of the product was the product of the number of moles of limiting reagent and the molar ratio of product to limiting reagent. The experiment required the temperature to remain constant. Conclusion. In conclusion, kinetics is a measure of the rate of a chemical reaction. This experiment enabled the determination of the factors to control, such as temperature, reactants, and catalysts. It helped in knowing how to vary them in order to increase the amount of products formed and minimize the time required. Kinetic data helped in the understanding of the mechanism of a reaction. The rate of a reaction depends on several factors, such as the chemical reactivity of the reactants, the concentration of reactants, temperature, and the presence of catalysts. If you want to find more works like this report on hydrolysis of Tert-Butyl chloride, kinetics, head over to ivpanda.com. It has a collection of samples with thousands of submissions covering virtually all academic subjects.